So before all the continents that we have today, we used to have one supercontinent named Pangea. Oh yeah, we're talking about everyone's favorite supercontinent, Pangea. Now the name Pangea means all land because it was all of the land. It was about 335 million years ago to 200 million years ago, and it started to split up 220 million years ago. I mean, it was never really a secret that South America and Africa kind of just looked like really big puzzle pieces that fit together. And it definitely didn't help that when we realized that on each side of the Atlantic Oceans, the rocks are the same. I mean, I literally have one of these rocks right here. This is called a diabase. They're found in Morocco, they're found in the Amazon River, Western Europe, and Eastern North America. So we knew some things, but we just didn't really know the extent of how far it went and why it even happened. And this goes for a lot of countries and a lot of continents. A lot of them really fit together like really fucked up puzzle pieces, and the rocks match so well. It wasn't until the coast of South America and Africa were studied right where that little puzzle piece fits, and they realized that the paleontological evidence, the geological evidence, it's all the same. But this was right before World War One, so it didn't really get a lot of traction until after the war, and then it kind of got shit on. I mean, geologists were coming up with all kinds of excuses to not believe in this. They were saying that there were just land bridges, so many land bridges, and then we found a horse that was found in like France and Florida, and they were like, wow, must have just been a really long fucking land bridge. But this land bridge idea wasn't based on any evidence, so obviously it quickly got thrown out. And eventually people really started to look at this Pangea idea. It wasn't until World War II where we invented sonar. Yes, I know, both world wars being involved in this Pangea. So it wasn't until the sonar was invented that we discovered that the bottom of the ocean was just a bunch of canyons and volcanoes. Like, I mean, right down the mid Atlantic was this giant canyon. And we called this big canyon in the Atlantic the Mid Atlantic Ridge. And then we started doing more studies, and then we started realizing that in the middle of the Mid Atlantic Ridge was a younger rock, and it gets older as it spreads out, showing that something was obviously pushing it apart. And when the scientists saw that the sea floor was spreading, they really scratched their head to come up with a cool name for it, and they called it sea floor spreading. Eventually, we got the idea of plate tectonics, which is just the idea that the Earth's crust is made of multiple plates, big plates and small plates, with the big plates moving slower and the small plates moving faster. And this was due to underwater volcano activity that was causing subduction. And this plate tectonic idea is how we have all of our mountains. All of our mountains are formed from either continents splitting apart or continents bashing into each other. And eventually, when Pangea split into two, we got two supercontinents, Gondwana and Laurasia. And I bring this up because during Gondwana and Laurasia is how we got the tallest mountain range of the Himalayas. Not the longest, I think that goes to the Andes, but the tallest is the Himalayas. And the Himalayas was formed when India left Gondwana and smashed into Laurasia at about 20 centimeters per year, which might not sound like a lot, but for example, America and Europe are splitting apart at 2 to 5 centimeters per year. So in geologic time, India was moving really fucking fast. But maybe I'll just have to do a video on Gondwana and Laurasia itself. I just wanted to talk about Pangea for a bit. Thank you for watching.